All right, college trig, we're on to the ellipse, 9.3. So ellipse is a collection of all points in the plane that the sum of whose distance from two fixed points, called the foci, is a constant. The three variables that we're going to be really familiar with that need to be important, make sure you have a clear understanding of where these are with your ellipse. A is your major axis, goes from corresponds to your A. Your minor axis goes with B, and your C is the distance from the center to the foci. So if I drew a rough sketch here of a ellipse, so my rough ellipse here with HK being the center, your major axis always goes to the long way. Okay, so this distance is going to be A, as this distance from here to here, this will be A as well. Your minor axis is going to be the shorter distance, so this is going to be our B, and this is going to be our B here. Okay, and then as for C, we'll have these points, the foci, or the focus, that are going to be out here. Those and this distance from here is C, as this distance here is C. All right, so those are the three variables that we're going to work with to come up with our equation and go back and forth between our graphs and our equation and our equations to our graphs. Okay, so here you can see the equations that you're given. Let's go ahead and look at this applet on Geometry Sketchpad, and we can kind of see how this is created. So if you imagine that you had a string attached at point F1 and F2 and a pencil on that, and you trace it around, what you end up getting is an ellipse. Notice that the string has to be longer than this distance from F1 to F2, because if it wasn't exceeding that distance, you couldn't move your string anywhere. Your string's fixed and your pencil would just be stuck somewhere in here, and you would just be moving back and forth on that line. So it's got to be greater than that. So with that idea, here we can see where our A, B, and C are going to be related. So if we know that our A is going to be this distance here, okay, and our A is also this distance here, we need to start relating B, C, and A together. So notice we can draw this triangle. It's very clear that this is C to our focus and B is here. But why is this A? Well, if you think about this string length here, the string length is 2A because it doubles up. Okay, so the string length has to go all the way to F1, and then it doubles up right here as we go over. So that double up region, we can think about it as it being added on over here. So this entire ellipse across here is 2A. So when we move our pencil up here to the top at B, we can see that if this string is 2A across, and I'm at the point B, which is the midpoint, then this segment has to be congruent to this segment. Well, because of that, 2A divided by 2, we get that this is A and that this must be A. So this triangle here is really going to be our key idea in linking our variables A, B, and C together and going back and forth from our equation to our graph and our graph to an equation. Again, no surprise, we got a triangle here in trig. So let's go ahead and look at an example here. So these will be important to write down and have in your notes here as an example, and what this is all coming from. Notice that for an ellipse that is squished down from top and bottom, and you have elongated left and right where a major axis is horizontal, your A value needs to be under your x. Okay, and that's going to change, and be careful with these a, b's, and c's. They're not directly corresponding to our Pythagorean theorem. Again, they're corresponding to our graph here, where this distance to the foci is c, the distance to the minor axis is b, and then this whole distance here is a, but that's also that same distance there, and then we get that relationship between the three variables. But notice our a will always be our major axis there. So our center is going to be the variables hk. To get to our foci, you can see that you take your center, and here would be minus c, would give us that point here. And if you added c, you get this foci here. So that's why we got the plus and minus there. The k, because it's not going up and down, it's maintaining its y-axis here at k. Our vertices, okay, so vertices, what we're going to call here, are going to be on your major axis out to these points out here. We'll refer to those as your vertices, where the ellipse intersects our major axes. All right, so let's go ahead and look at, oh, this is now if our major axis is a horizontal line, and we're kind of squeezing this circle from left and right. And again, notice your A is now with your Y, because it's elongated on the y-axis. So you got to realize that those two interchange when we're talking about a major axis being vertical, as it is here, or when it was horizontal before, the A was under your X. So again, all the same logic follows here, but remember your H stays the same here with your foci, and you're adding your C to your K value because it's going up and down and things like this. And then again, now your vertices, as opposed to being left and right from each other, they're vertical from each other, and you'll do that. And just like before, with parabolas, you really first got to decide whether you're dealing with something with a major axis being vertical or a major axis being horizontal. And as long as you're given 2 points, you can decide which equation you're going to start with, and that's the entry point of these problems. Because, you know, if you're given an h and k here, and you know that your vertex is above it, then you know you're dealing with a major axis that's vertical, and you'll have this family of functions here. And then if you're given a hk here, and let's say you're given a foci that's left and right of it, well then again, you know your major axis is horizontal, and you'd have to deal with the previous equation that was shown. So before we get into our examples, let's go ahead and pause it here and start video 2.